Hello, and welcome to part 3 of the Trigonometry Review from Stevens' Matrices, Vectors, and 3D Math, a game programming approach with MATLAB. Alright, so in this part 3, we're going to consider trigonometry as a collection of periodic functions, right? We started off, part 1 was we thought of trigonometry in terms of triangles. Part 2, we consider trigonometry in terms of the unit circle. And now we're going to consider trigonometry as a collection of periodic functions, specifically of a continuous variable. And that continuous variable will be denoted by t, right? And now we're going to think of this t. We're actually going to travel around this unit circle, all right? And our parameter, our variable, will now be t, and we're going to track what happens to cos t and sine t, right? We're going to say let x be cos t and sine, or y be sine t, just like we did in unit circle trig. And we're going to plot these functions, right? And it's worth keeping in mind that t in this case must in fact be in terms of radians. I mean, conceptually, it doesn't make any difference, but if you're using software, it will, almost every software that I know of, with the exception of a TI when you change the mode, will expect the argument of any trig function to be in terms of radians. So we're just going to track cosine and sine in this particular demonstration, and we will worry about tangent later. Right. So, and I'll show you the graph in a second, but let me get into full screen mode so that we can maybe capture more of this page. Okay. So I think we can get cosine t along with this unit circle. So let's just look at this chunk. This is the part of the cosine curve I want to focus on when t goes from 0 to 2 pi. So it's one time around, right? Okay, so if you look at this, when t equals 0, right, then that means I'm right here, and that the cosine, which is just x, is going to be 1. So that starts me here. When I get up here to pi over 2, my cosine is going to be 0, right? That's just the x value. Sorry, I'm having trouble with my pen here. Right, so that's this 0. Then when I go all the way around, theta equals pi, notice my x value is now -1. When I go all the way around to 3 pi over 2, or pi and a half, my cosine is back to 0 again, so that gives me this point. And when I go the whole way around, one complete revolution, that angle in radians is 2 pi, and I'm back at 1 again. All right, so that gives me this point. And so notice you get a little tracing of the cosine curve, and to fill in the other points is a little trickier, but at least you can immediately distinguish the cosine curve from the sine curve, right? And as you can, it's quite obvious at this point that if you go past 2 pi, right, or if you go to the left of 0, you're just repeating those same things. So once you get this chunk of the curve from 0 to 2 pi, you just extend it. You just repeat it periodically, right? So that's your cosine curve. It's the cup, right? It would hold water on the 0 to 2 pi domain. Now, just for the sake of having both of these things on the screen at the same time, meaning the xy axis, or in this case the ty axis and the unit circle, I'm going to trace out the sine curve on this same Cartesian coordinates. So all I'm going to do is I'm going to play the exact same game, only instead of tracking the x values, I'm going to track the y values, because those are the sine. So there's my y value. So when t is 0, I'm going to get a sine of 0, right? When t is pi over 2, I have sine of t is 1. So that looks like right about here. When t goes all the way to pi, sine is back down to 0. When t goes to 3 pi over 2, sine is at negative 1. Right, looks like I'm right there. And when t goes the whole way around to 2 pi, sine is back to 0 again. So you can see, if you connect the dots, we've got a different curve. We have the sine of t. Right? Similar shape, actually identical shape. One's just actually a shift of the other. But it starts off different. Sine. So now I'm going to scroll down so that you can see how it came about. And so there's the sine curve on 0 to 2 pi. And when you go beyond 2 pi, it repeats itself. Or when you go into the negatives, it also repeats itself. Right? So notice the cosine curve is the one that appears to be, it could hold water, right? It gives you that sort of cup look right here. Starts at 1. The sine curve is more that roller coaster, and it starts at 0. Okay, so here I'm going to go over a few properties that are true of both of these. In both cases, for cosine and sine, they have periods of 2 pi. It means once you go around that circle once, it starts repeating itself. What that means is that if you take any angle and add any multiple of 2 pi, it's the same thing as taking the cosine of the original angle. And the same goes for sine. All right? And these are a little trickier in the sense that any multiple of 2 pi will give you a cosine of 1. And that's because basically you're over here where x is 1. You go around once, you're back at 1, back at 1, back at 1. If you take any odd multiple of pi and take the cosine, all right, that's how, by the way, this is just how you generate odd numbers. So you think of it as 1 pi, 3 pi, 5 pi. Either way, you end up here, and the y or the x value is negative 1. Right? And if you end up on any odd number over 2 pi, meaning you're either here or here, the cosine is 0. Right? And if you play the same game down here with sine, what you notice is that any multiple of pi, the sine of k times pi, or k times pi is actually any multiple of pi. So you get a 0 here, 0, 0, 0. And if you have a multiple of pi over 2, right, so this is odd, and it depends whether it's a 3 or 5, but what you're going to either get are positive ones and negative ones, right, and they oscillate back and forth. Okay, so that's, and all this stuff is not totally necessary. The terminology is a little cryptic in there. I understand that. But hopefully you certainly recognize that this means sine is a function with period 2 pi. And the same goes for cosine. And you can even see it. I mean, you can see it when you look at this graph right here or here. And you can see it if you were to look at the unit circle. After you go around once, you'd just be repeating yourself. All right. So that's trigonometry as a collection of periodic functions, specifically a continuous variable, and it leads to a continuous and, in fact, differentiable function. All right, so that wraps up part 3, and I will see you at part 4 when we start talking about altering these curves, move them around, stretch them, shrink them, give it a higher frequency, change the period, things like that. But that is the next video. So I will end it here. Bye.